All right.
Yeah.
Okay. So I believe this is recording. I hope this is recording. And if it's not, then we'll have to do it again. It looks like it is recording. So, okay, so this is class for April 7th. CEG 111. We are moving into our GPS portion of the class, and so I wanted to just lay it out for everybody here so we all have an idea of what we've got going on and what we're going to be doing. So I just mentioned to everyone who was in here that Test 2 and the Lab Queries quiz and this ArcGIS online assignment were all due today. If you need more time on it, just tell me, and you can have this week as well. You will want to start working on this GPS stuff also, because you don't want to get further behind. Just let me know if you need more help, and I'm happy to give a second chance on the Lab Queries quiz even, and I'm happy to do some individual time if anyone needs some help with queries before you take it. Just let me know, contact me individually. So we're going to start introduction to GPS and GNSS. GPS is the Global Positioning System, and GNSS is the Global Navigation Satellite System. They are similar, but have some slight differences, and you're going to learn all about that in this GPS PowerPoint here. I can talk over this this PowerPoint, but I'm not going to do it during this session. I could do a recording of it and just talk through GPS and the GNSS, but you can get all of the information from here as well. We're going to have a final test in this class, test 3, and it is going to primarily come from this PowerPoint. All right. In addition to that PowerPoint, there is more detailed information on this Trimble GPS tutorial. Trimble is a GPS company that makes professional grade GPS units. And they've got a nice tutorial here that is worth looking at. It's a little bit more in depth. And so consider that your reading, okay? There's also a supplemental link from gps.gov. It's our government GPS site, the official US government site that talks all about GPS. GPS is a government-run system. Ours, the United States system, is called Navstar, originally conceived to track troop movements and to drop bombs in windows. It is now highly, it's more used for civilian use than military use now, but it did grow out of the military, like so many things. So these days, GPS is incredibly common because everyone has it on their phone. We in the GIS world, we often think of GPS as a way to collect and capture data to build our GIS layers, right? So everyone uses GPS to find Starbucks, or to find your favorite fishing hole, things like that. In the GIS world, we often use it to collect data to create vector-based GIS layers, points, lines, and polygon data. We've collected data and we've created data in other ways. In the editing exercise, we did some heads-up digitizing to create building polygons and to move roads, and we've created data by converting addresses and XY coordinates to points. GPS is another way that we create data. So review these learning resources, especially that PowerPoint, and test 3 will mainly cover that. Now, you can't see this stuff below, this module 10 you can't see, module 11 you can see some of it. Module 10, we're not going to do recreation grade GPS. That's using like Garmin GPS units. Recreation grade is often thought of as consumer grade GPS, And that's in contrast to professional grade GPS. So your phone and Garmin GPS units are both consumer grade. They don't have the accuracy necessary to really be considered a professional grade kind of thing. So we're going to look at a GPS app on our phones tonight. And just as a kind of introduction into GPS, I'm going to show you a few things on my phone, and we'll do a little assignment this week using GPS on your phone. We're actually going to do our professional grade work with Esri software. There's an app in the Esri stack of GIS software called the Collector app that integrates with ArcMap and ArcGIS Online. So in a week or two, we'll be using that. And one of the differences that you get with a more of a professional grade kind of GPS and application is the ability to build and design your GPS, or build and design your GIS. You actually get to decide what features you're going to collect, point signs and polygons, and even come up with your database schema or the attributes that you want to capture for each feature. So that's a big difference between kind of a recreation grade or a consumer grade also. In addition to them not being as accurate, a big difference also is not really the ability to build out a full GIS database full of attributes. So if you were going to go collect tree information with a Garmin GPS unit, just a $100 Garmin GPS, if you wanted to walk up to each tree and not only GPS it, but you wanted to put in the tree name, the tree type, the height, the DBH, the condition, you wanted to actually build out a database of attributes. That's the kind of thing you can do with the professional grade software and applications and GPS units that the consumer grade don't really give you the ability to build that true database of information, of attributes that we really think of when we think of a GIS layer, right? So the GPS the app I'm going to demo tonight is just you can use it for free. It's kind of a recreation free thing you can put on your phone. It's called Gaia GPS. There's 100 different options you could use. But we're going to see that and we'll talk about it as we go. Okay? So make sure to review this PowerPoint closely. Make sure to read about GPS through the Trimble site. And if anything's confusing, you can even read about it on our government's GPS overview site as well. So tonight is Introduction to GPS and GNSS, and also it's kind of a look at kind of consumer grade collecting GPS data that almost anyone in the world, or really everyone in the world, can do because their phone has GPS on it. It's not using it for a professional, in a professional kind of setting where you're really building a GIS database. Now, that said, you can use that for this, and I'm going to show you how you can get the data into a GIS database. Later on, and next week and the next week, we're going to be using the Esri's world of doing this to build your GIS data, use GPS to build a GIS database. So the learning activity is a little bit light right now because I have not written it all up. This class is usually held in the classroom and we just kind of do it all together. So I didn't really have it written up really well. But what I've started doing is building out the assignment here in a Google Doc. And this is kind of the basis of it. Okay, so Bruce is not going to make it. Okay, so this is kind of the basis of what we're going to do. And for our assignment. And I'm going to demo some of this stuff to you. So let me get back here. All right. So this assignment here in Moodle is really going to follow along with what we write up in here. all right? So the objectives of the work this week are to record tracks, record waypoints, understand some file formats, export data, visualize data, as well as convert to a shapefile. So when you're working outside of the professional grade GIS environment, when you're collecting data with a consumer grade Garmin $100 GPS unit, or when you're doing it with one of these apps on your phones that you can get for free, the ones like Map My Run or Map My Hike or Gaia GPS, a lot of these apps are made for recreation purposes. When you collect data, when you capture where you walk or where you hike, that line is referred to as a track, okay? So just a little bit of terminology. Tracks are vector lines, okay? So in the GIS world, we've talked about points, lines, and polygons. When you have a shapefile either has points, lines, or polygons in it. When you're collecting data with one of these kind of apps, these lines are called tracks. And if you collect points, they're called waypoints. So these are vector points. So these are just some terms to kind of be familiar with. Tracks and waypoints are the lines and the points that we've been talking about this semester when we've been talking about vector-based GIS data. Also a difference when we talk about collecting data with these apps, we don't use the GIS file formats that we've been learning about this semester. We've been learning about shapefiles and geodatabases that have feature classes this semester. Those are Esri-based formats. Pretty much any of these apps that you can use for free, or some of them you can purchase. When you collect the data and you want to view it outside of the app, you export it to a GPX or a KML format, okay? GPX stands for it's for GP Exchange. It's an open data format for exchanging GPS data, GPX. KML stands for Keyhole Markup Language. Keyhole Markup Language is the native format for Google Earth, and it's kind of become one of the de facto data transfer standards for mobile apps and the internet, because it just works really well with mobile apps and the internet. So we're going to use Gaia GPS, but almost any one of these apps that you use, you can export the data to GPX, all right? The problem with GPX data for us is, what if you want to look at it in ArcMap? ArcMap doesn't support GPX data. So you can't click the Add Data button in ArcMap and look at GPX data. So we're going to look at a couple of different ways to convert GPX to shapefiles so that we can view it in ArcMap. So it can be viewed in ArcGIS, all right? So I'm also gonna show you how to, a cool visualization tool called GPS Visualizer that lets you look at GPX data, all right? So if you have some other app that you like to use and you don't want to use Gaia GPS, I don't mind if you use some other app, as long as you can collect, as long as it allows you to record tracks and waypoints and export them. And a lot of them do. So, all right, so we'll look at some GPX and some KML data, really common formats that you see these days. They're just not necessarily true professional. Well, Esri doesn't support them. Esri wants to tie you into their data formats, okay? So another thing, these instructions are for an iPhone. These instructions and demo are on an iPhone. If you are using an Android, the interface will be different, but you should be able to figure it out. Okay. All right. So Gaia GPS, the first thing that you'll need to do is to go to Gaia GPS, create an account, and then install Gaia GPS on your phone. Now, this is what the Gaia GPS website looks like. And I'm logged into my account. I haven't done a lot with my profile or anything, but what I wanted to show you is right after you create a profile, or right after you create an account here, you can download it to your phone, or you can just go straight to your phone and do it. I did it on my phone, and then I created an account here. And you can also see some tutorials on things like recording a track. So if my instructions here aren't that great, you can find some instructions online and in here on how to do that as well. Okay, so without further ado, let's see if I can show you some Gaia GPS stuff. And I've got all kinds of stuff on my phone and text coming in. So, all right, maybe it is there. Okay, so here's my phone. See if I can get rid of some of this stuff. Okay, now my phone's been acting pretty weird too, so hopefully it works. My button, my little home button keeps messing up. So let's see how, hopefully this thing works well. All right, is everybody with me still? Everybody good?
Yep.
I'll try and keep this demo pretty quick. All right, so from my iPad, I'm gonna open Gaia GPS. Now the resolution's not that great, but it's pretty cool that you can see it at all. These two buttons up here, when you first start, this record button looked different the first time I started recording, but essentially this button right here will center you where you are, okay? It'll put you in the center of the map, okay? This button, that add button, if I click on it, I can also start recording a track, adding a waypoint, and I could even create an area here. I could take a picture and I could import a file. So if you had an existing GPX file or KML file, you could import it to your map so that it's there. So I'm going to show you a GPX and a KML file of all the trails in the Linville Gorge Wilderness that's on the way up to Boone. You could download that, import it on your map, and have that data to help you navigate around. So we're going to mainly work with tracks and waypoints. You can create areas as well, which are polygons. And we're not going to mess with routes, so don't even worry about that. So I'm going to click create or record there, and mine is recording. And you can see here it's starting to record. Okay, now I'm in my house, in my basement. GPS does not work well at all if you don't have a clear line of the sky. You need to have a clear view of the sky for GPS to work, but I just wanted you to see it start, and you can take pictures along the way. So I'll take a picture of my screen. If you do this, I'm going to use this photo, and then I'm going to click here to stop that track. Well, I'm going to hit with my finger right here to stop the track. And I wasn't actually moving, so I can pause recording. I can delete the track or finish the track. I'm going to click finish it just for the heck of it. And it wants me to give it a title. By default, it calls it track with the date and time. I'm going to click right there and just call it demo from my basement. Essentially, the error is just going to be through the roof this way. I can tell it what kind of activity this is, biking, camping, canoeing. Of course, I'm not doing anything. So, you know, whatever, I could pick whatever. Let's say I'm dirt biking. Wouldn't that be nice? But no, I'm in class. I can choose a folder to better organize my work that I'm doing here and all kinds of stuff. So I'm going to save that one. Okay. And it shows it on the map. All right. So when I go back to my map, if I zoom in on it, you'll see this little purple track I walked right before class. I walked that and I recorded this track out in front of my house and I saved it, just like I did that one in my basement that didn't actually save anything. So you want to start a track and you want to walk around. You can take some pictures as you go. And these are waypoints that I took as I went. There's a little, I took pictures as I went and it shows them on the map. Okay, so that's pretty neat. So the pictures are tagged with coordinates. Here's my wife gardening over there. Okay, so what you're going to do is you're going to use the app to collect, I think I said 3 different tracks. You can collect like a fence line, collect a sidewalk in front of your house, collect a property line, walk anywhere. And then I asked you to collect some waypoints. Waypoints are things like a tree, a bird feeder, a bird bath, a manhole, anything like that. So it's just to practice collecting some tracks and some waypoints. If you take pictures while you're walking, it automatically puts those on the map here, but they don't export out that well. So you want to actually, when you're walking, you want to click this plus sign right there and tell it to do a waypoint. And it'll put a waypoint. You can just walk around and stand over whatever point features you want, a manhole, a tree, and click a waypoint. Name it, whatever it is that you are GPSing. Now, make sure to explore the settings. The settings here, you have to sign in under settings. So you have to sign in under settings. And you can do different things like change the units. Notice it's got the datums, WGS84 is working with the coordinate system and all that stuff. So go in here and explore the settings some. You can work, it's got a compass. Spend a little time just exploring it. You can look at your trip information. And then if I go down to my saved here, it's going to show you, there's my demo in my basement. And then here's me walking around the cul-de-sac. This is the one I did right before class. And if I click on that one, it's going to bring it up. And once it's up, as showing the main map, if you click these 3 dots right here, which I'm going to click with my finger, I can export. If I go to export, it's going to give me GPX or KML. I'm going to pick GPX, and I dumped it on my Google Drive a few minutes ago, so I'm not even going to do it again. I just clicked Google Drive, and it put it on my Google Drive. So that one did not have any waypoints. If you have waypoints, you'll be able to export those as well, and you're going to need to have waypoints. You can see I walked 375 feet. I walked for 2.5 minutes, and there was 10 feet in elevation ascent. Okay, so that's how you export. You go to what you collected, and you click these 3 dots up there. Now, don't be afraid to explore and look around on Google Map, on YouTube or Google for people showing you how to use this app as well, and just explore with it some. So now what I want to do is I want to jump back over here and just kind of relay this to the bare bones assignment. I'll add a little bit more into this. This is kind of the bare bones assignment that I have up so far, if I can find it. All right, so The objectives are to record tracks and waypoints, understand the GPX and KML formats. I just showed you how to export it from the app. And when you export, let me go back to that. When you export, maybe you want to, I put it to my Google Drive. You could email it to yourself as well, okay? Emailing it, if you don't have your Google Drive set up, emailing it might be the easiest way, and then just download it from your email. All right, so once you export it, we're gonna visualize the data here in GPS Visualizer. So, I mean, we were visualizing it already in our app, right? I mean, you can visualize the stuff right here. I'm already checking it out here, and you can even, you can look at the trip information there. Elevation was around that, and so my current speed. So, you can do some visualizations right here in your app. But for now, what we want to do is look at this cool GPS Visualizer app because it's cool. So if I go, here's my Google Drive, and there's that GPX file that downloaded. So I'm going to right click it and I'm going to download it, and it's just going to dump to my downloads folder, which is fine for now. And now I'm going to go to GPS Visualizer to show you this cool program. If you're not a GIS person, this provides additional ways to look at this data that you've collected with your phone. So you can, if you've got a GPX file, you can pick the GPX file, see, cul-de-sac.gpx, and you can map it in all kinds of programs. I can throw it in Google Maps, map it, and it shows my GPX data in Google Maps. Now, you get this weird API key thing from Google Maps where you can just close it, and you can do stuff like look at it with the Google Aerial. All right, there's my house. Oh, wow, look how new that data is. That camper hadn't been there for that long. So, yeah, so there's me walking around this little cul-de-sac, okay? Just really a cool way to visualize GPS data. What if you wanted just a static JPEG to throw on a website? You can get a static JPEG off of this thing. It's just that when you put it in Google Maps, it's an interactive internet map. You can just map it to a JPEG, and that's literally just a JPEG that you can right click and you can save the image as a JPEG. All right. So GPS Visualizer's pretty cool. It'll even let you do like an elevation profile. Let's look at this thing with an elevation profile. And that makes it look like there was a lot of elevation change. There was not, okay, at all. It's between 644 meters and 658. And then there's a lot of error. There's 3 times the error vertically in GPS than horizontally because there's no, the earth is between you and the GPS units below you that would help to get that Z value. But if you want more detailed options, you can go here and look at something like the profiles here, and you could tell it to make it wider. Let's make it 800 and not as tall, and this will flatten it out. And if I choose my GPX file here, you can tell it you want distance to be in, well, it's in US here, it's in meters on the other page. You can change all kinds of stuff, and here it's going to get the elevation data from a DEM. You can change all these settings and even the file format. PNG, JPEG, those are raster-based images. SVG, you can edit. So JPEG's compressed, PNG's a more high resolution one, and I'm going to show you if I chose SVG what you could do. So I'm going to draw the profile here, and you can just change the the width, how wide and tall it is to make it look a little better. Okay, if you make it not wide, it is oh, is he waiting? Oh, hold on. Oh boy, I didn't see that he was waiting. Okay, sorry, Steve was waiting. Sorry, Steve.
It's all right.
I didn't see that you were there.
It's okay. Everything's cool.
Yeah, so the video will be there, so at least we got that. So this is visualizing our GPS data in the app using were you still on your phone watching?
No, on my laptop now.
Okay. All right, so you got a lot more control over the elevation profiles in here. And it's nice to be able to do that. So an SVG file is a scalable vector graphic. If you did this and you saved it as an SVG file, you can put it in a program like Adobe Illustrator. And in Adobe Illustrator,
Cut it out.
what's that?
Nothing. Never mind. It's my dog's barking.
In Adobe Illustrator, I started with the GPS with the elevation profile right here from a bike ride in DuPont. And from a scalable vector graphic, I put it in Illustrator and I made it look like this at the bottom here. If I can find it. I made it look like this profile right there. So starting off as a, as a kind of a rudimentary looking thing, I was able to make it into something like that. So, so GPS Visualizer is a really cool tool for visualizing GPS data. All right. So moving on, let's look at this GPX file real quick. I wanted to show you something about GPX files and KML files. I wanted you to better understand these file formats. GPX and KML are what we refer to as human readable data formats. They're not compiled computer programming code that cannot be opened. Like a shapefile, you can't just open a .shp or any of the files that make up a shapefile and look at the contents. You see a bunch of binary gobbledygook you can't understand. GPX and KML files are tagged base formats, a lot like hypertext markup language, HTML, and you can look at them in a text editor and they just look like stuff you can understand. You can see this track point, you can see the actual coordinates of it, the elevation, the time that it was taken. So GPX and KML are human readable. They have these tags. You have an opening and a closing tag. And this is the elevation tab for that one point. Okay. And within it, there's the track tags that make up that single point along that line. So KML and GPX are both like that. You could actually write it by hand if you wanted to and create a file. So that's GPX data. Now, while we're at it, let's just look how easy it is to find some data. If you go to Linville Gorge, if you do a quick Google search on anything you're curious about, Linville Gorge KML, you'll see on linvillegorge.net, there's this master KML file. And you can see it's a KML file right there. And if I just left click on it, it downloads it. Now I've been saying KML. KMZ is a compressed KML file. You can work with them both. So I'm just going to download this KMZ file. And if you double click a KMZ or KML file on your computer and you have Google Earth loaded, it opens it in Google Earth by default. So it's a pretty neat thing to be able to just get data like this right off the web. And I showed you how you could import a file like this into into Gaia GPS. So this is all the trails in Limble Gorge. Pretty cool. Now these are actually not all Forest Service sanctioned trails. These guys have a lot of kind of user created trails that you won't see on an official Forest Service map or anything like that. But just like that, I can get all this data in KML or KMZ. All right. Okay. So the final thing that I want to show you is, what about using this KML and KMZ data in ArcMap? So when you go and you use your phone and some nice free app like Gaia to GPS a trail that you went and hiked or rode, or maybe some place you went hunting, and you want to create a map in ArcMap and include that data, ArcMap wants a shapefile or a geodatabase feature class. So I've been using a tool called DNR GPS for a long time to convert data from GPX or KML to shapefiles, and we're going to use that this semester. There are a lot of other ways to do this. The free GIS program called QGIS will do this. There are also online converters, online GIS file format converter, that will do things like this. I've actually not used them that much, but here's one called mygeodata.cloud converter that says it'll go KML to shape. Okay, right there. So input any format. Let's see if it'll do GPX to shapefile. Oops. Goodness. Check. Yes, it will do that. So maybe we'll look at both of these to do this. And I don't care which one you use, but I want to show you DNR GPS because I've been using it forever. So in Moodle, there are some instructions for using DNR GPS. Again, you are not required to use DNR GPS. If I can find it. Does anyone else have 78 tabs open in their web browsers? All right, so here's some instructions for using the DNR GPS application. And here's the application. Now, when you download this thing, it's not something that gets installed, okay? And what I mean is, it's a zip file, and if you go to extract it, it's just a folder, okay? Put that folder anywhere you want. Put it on your desktop, put it in your documents folder, just extract the folder. And inside of that folder, there is this DNR GPS.exe file. And it's in a zip file, so it kind of messes up the picture there, but it looks like that. See that icon right there? When you extract this folder from that zip file and you put it on your desktop or wherever, you just go into that folder and double click that DNR GPS.exe file, and it opens the program. You don't have to install it. I right clicked it and I pinned it down here. So all I have to do is click it. You do have to unzip the folder, and it opens this. It's kind of an old program and it looks kind of antiquated, but you can load from a file, and it lets you load from a bunch of different file formats. I'm going to load from a GPX file. I could load from a KML file. I could load from a text file, GML, CSV from a shape file. So I could load a shape file in here, and then I could save it to a GPX file. I'm going to load my GPX file in here from my GPS today. It's in my downloads folder. So I'm gonna load in my cul-de-sac GPX file, and it loads it in here. And once it loads, so you file load from, and then on a file save to a file. And I'm gonna call it a shapefile. You can do 2D or 3D. If your phone collected a Z value, you could look at it in 3D in ArcGIS if you saved a 3D shapefile. We're not gonna do that, so it doesn't matter which one of these you pick. What I usually do is before I change the file format, I click this file one time, and then I change the file format because I've got it cul-de-sac GPX, and I'm gonna change it to shapefile, and I'll end up with a cul-de-sac shapefile. So I don't have to re-put the name in there. I'm gonna save it. Click OK. All right, so if I go look in my downloads folder now, that right there was just created at 4:51. Remember, a shapefile is made up of at least a .shp, a .shx, a .dbf. If it has a PRJ file, it means that the projection information was saved, and that's good. So this is the shapefile, all of those things together, and that's my GPX file. Now that I've got my shapefile in ArcMap, I can click Add Data from my Downloads button, or my Downloads folder, sorry. I can find my Downloads folder. Now I have a shapefile that I can look at somewhere. Where is it? Heat Downloads, cul-de-sac. I live on a cul-de-sac. There it is. And in here, I could start editing and edit the data and all that kind of stuff, all right? So translating data between formats is something we do a lot of in the GIS world, okay? So having some tools at your fingertips to do that is important. There are some tools in our toolbox for converting between formats, but they can be a little clunky. I think DNR GPS is a quick, easy, clean way to do it. I like using it. I use it a lot. These online converters appear to have gotten a lot better. I've been around so long that I've been doing it different, the old school way you could say, but I'm gonna go in here and I'm going to pick that GPX file from my phone from earlier, continue using my geodata converter, and I'm gonna convert it to a shapefile. And this will even merge output files. So you can put multiple files in there and merge them. That's pretty nice. We'll see if this thing works or not. Download, your data were converted. So there you got two quick and easy ways to convert your data. I'm gonna call this home. I'm gonna put it in my downloads folder, and we're gonna see if it worked. Cul-de-sac. All right, look at all that stuff it created. So I'm going to copy this cul-de-sac folder from my zip folder. I could also extract all here, and I'm gonna let it put it in that home folder. So inside of this home folder, there's gonna be a cul-de-sac folder. And let's see what that stuff looks like in ArcMap. So all these converters do things a little bit differently. Home, cul-de-sac, it created a waypoints, the track points, and the track lines. So the track points are all the points that make up the line, and the waypoints were, I guess, those, ooh, look at them, they're a little bit off. So not even sure why it did that. Those 2 points right there were from the pictures I took. The pictures will not be part of it though. I can identify it and see what's there. So it shows there's a photo, but that photo doesn't come down with the GPX file when you export it. It knew there was a photo, but it doesn't get attached to it, okay? All right, So your assignment is to use Gaia GPS to collect a couple tracks, collect some waypoints. I would like for you to view them in the GPS visualizer after you, so collect 3 tracks, 5 waypoints, export to GPX. KML, if you'd like. Go to GPS visualizer and look at your GPS data, and then convert it to a shapefile. You can refer back to this video, convert to a shapefile, and view in ArcGIS. Okay. And you're going to either use my GeoData Converter or the DNR GPS app. Use. Okay. All right. So, okay. So that's the short of what I wanted to show y'all. So take some time to experiment and explore with the app. Take some time to maybe find some GPX data or some KML data online, somewhere you like to go, something you like to do. I was going to show you one other app I use a lot is Strava. This app is how I capture all my runs and my rides or anything like that. And from here, this is my kids last night on our this is a 1.9 mile scooter walk we went on, and it's awfully slow. I don't know why it doesn't show me the map. Really, I just wanted to show you the map, but it's not showing it to me. So I use this app usually for what I do. And from here, you can export right from here, export to GPX. And so if I'm making a map, a hiking trail map, and I go out and hike stuff, I usually collect the data with Strava and export it right here. And it's pretty neat to show it in something like GPS Visualizer if you want to see it even in more detail. But this shows an elevation profile too, but you can't export that elevation profile. All right. So that's just another app that's free that you can easily use as well. All right, so I'm going to stop recording and I'll make this video available. I guess I'll have to upload it to YouTube. It'll probably take forever, but it'll be up eventually tonight. And I'll try to put a few more details in that assignment and maybe a few screenshots. That won't happen super quick, but it'll be up in a day or so. All right. Email me if you have any questions.